Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying this journey. Like it's gonna be a year-long journey, guys. So we have started with data. We have done playing with data. Okay, now we are moving into the part of machine learning. Okay, we're gonna step into each and every algorithms, their details, and then coding part like those things, and then we're going for a deep learning and then generative AI, and then finally we're gonna have some surprises. Okay, like how this field will be, what are the career things, like those things we're gonna see. So it's gonna be a year-long program. Make sure guys you just subscribe to our channel so that you can able to watch our videos, because like every day we will be posting a video, right? So yeah, so that's a thing. So if you guys are doesn't subscribe till this point, please subscribe to our channel and press the bell icon so that you doesn't miss any of our videos. And if you guys have come to this stage, that this session, please make sure that you guys watch all the previous session videos so that you guys can have a better understanding of what we are gonna tell something. Okay, what we gonna tell. Okay, so yeah, guys, actually we have started to machine learning for the past 4 to 5 sessions, I think so. Okay, I hope like it is like completely gonna be, which depends on playing with data. Okay, how we gonna play with the data, it's that. Okay, so we need to first of all understand how, what are the ways of playing with data, like going for data uh, selection, data collection, the source of data, what are the EDA that we perform, how we gonna make the data digestible by our model, everything we have seen. Okay, and then we have seen some codings also like Python or an SQL. So those things which are like a basic thing where we gonna build all the models on top of it. And for the past 3 4 sessions we have been looking into machine learning. Okay, today we're going to see the first algorithm that we are having in machine learning. Okay, so that is linear regression, unleveling the relationship in data. So like I'm very much excited, guys. Hope you guys are the same. Okay, yeah, today the first concept of machine learning, that is which is under supervised learning, and which is regression. Okay, I hope like you guys know what is regression, right? Regression means it is gonna predict the continuous values. Okay, it comes under the supervised learning. So today we're gonna see linear regression, unrevealing the relationship in data. Okay, so yeah, what is meant by linear regression? Linear regression is the fundamental statistic techniques used in data science to explore the model relationship between variables. It's a powerful tool for predicting outcomes and understanding how different factors influence one another. Okay, I hope like it gonna be confusing, because like the terminology is gonna be confusing. Put it in simple manner. Okay, let us see. I have an example for you guys so that you can understand what is this linear regression. Okay, we gonna we are having a total number of hours the students study, and based on that their marks. Okay, so whenever the students study for a long time, okay, consider a student study for an hour, he gets 1 mark. 2 hours, 2 mark. 3 hours, 3 mark. 4 hours, 4 mark. Like that, it continues to 10 hours, 10 mark. Okay. Now you can see there is a relationship, right? Whenever the student study for more time, the mark is also more. So this kind of relationship we can do by using regression, that is linear regression. Okay, because like whenever the hours increases, the mark also increases, right? The study hour increases, the mark also increases. That is how you can easily able to correlate what is this linear regression. Okay, hope you guys have understand. So this is what linear regression, guys. This is the first algorithm. Make sure the guys from now onwards you guys need to know about the theoretical concept, because like the next session, like, so we're gonna see the coding part of this linear regression. So you need to have a idea of what is this theory, so that only you can be able to understand whenever we go for a coding. Okay, so what is a linear regression? That is we're gonna find the relationship between two variables. Okay, that is whenever, for example, whenever the hours of a study of a student increases, their mark is also increases, like 1 to 10, then their mark is also 1 to 10. So that's a way of relationship between the two variables of hours of study and the marks. Okay, so that is what about this linear regression. There's sample example, I will say a simple example. Okay, yes sir, over to you.
Yes. So, guys, if you have come to this session, so go and watch all the sessions 5 to 10 times so that you'll do reinforced learning and also you will absorb the information, digest, and apply. So, do all the assignments, then come to this session. So, let us start with linear regression, unveiling relationship in data science. So linear regression is a fundamental statistical technique used in data science or AIML. So to explore and model the relationship between variables, that is the main key element. It models the relationship between variables, and it is a powerful tool to predict outcomes and understanding how different factors influence on one another. Okay, so linear regression, it's a very powerful tool. So if you understand this, so you will understand other regression models, other regression algorithms. So go step by step, absorb the information, digest, and apply. So do all the assignments, and let's move to the other slide.
Yeah, sure, sir. Okay. So moving on, guys. Let's see. Okay, we're gonna see what is the dependent and independent variable. Okay. So guys. These are the terminologies you guys need to clearly understand, because like most of the interview questions is based on this. How we are giving importance to overfitting, underfitting, bias variance, right? This is also very important. Dependent and independent variable. You guys need to have a perfect understanding. Okay. What is a dependent variable? The variable that is being predicted or explained. It often referred to as an outcome variable. Independent variable, the variable that is used to predict or explain the dependent variable, also known as a predictor variable. Okay, I hope like it will be confusing. Let's have the same example. Okay, the students study for hours and they are getting a mark, right? So mark is the outcome, right? That is the dependent variable which depends on the independent variable, that is the hours of student study. Okay, now I hope like this is a very easier understanding. Marks is the outcome which is dependent variable, and the hours the student study, right, it is the independent variable. That's it. Okay, so outcome is the dependent variable which depends on the input, that is independent variable called as the hours the student study. Okay, so I don't want to confuse more, like this is what independent and independent variable. Okay, have it as a simple manner. Okay, so yeah, sir, over to you.
Yeah, so dependent, if you understand word dependent, means it is dependent on something. Independent, which is not dependent on any variable. Here, when we talk about variables in regression analysis or machine learning, so dependent and independent variable. When variable is dependent on other variables, so then it is dependent, and if it is not, then it is independent. So so dependent variables are, they that is being predicted, okay, or explained. It is like often referred to outcome variable in machine learning. So independent variable is when it is predicting or explaining the dependent variable, also known as predictor variable. So it's like you have to understand dependent variable is being predicted or explained. It is often referred to as an outcome variable because it is dependent, right? It is dependent on the outcome variable, or it is dependent on the other variable. Whereas independent is, it is known as the predictor variable. So it is not dependent on other variables, okay, or variable. So that is the main difference between dependent and independent variable. So in the name you can understand dependent, it would be dependent on the outcome variable, and independent, whereas it is known as the predictor variable, okay, or you can say it is independent, it is not dependent. So that is why they have chosen the name as dependent and independent variable. So let's move to the other slide.
Yeah, sure, sir. Okay, guys, this is also very important. Okay, so the linear regression equation. I hope like you guys have already learned about this. What is the formula for line? Okay, what is the formula for line? Just ping in the comments. I know everyone knows it. Okay, y is equal to mx plus c. That is what the formula. That is what linear regression do. Okay, you guys doesn't believe or not, that is what a linear regression. It gonna, we will scatter the data points and we will fit a line. That's it. In order to just predict, we will try to make all the data points to cover in that line. That's the only thing. Okay, so what is the equation of linear regression? It is y is equal to mx plus c. What is y? It is dependent variable. What is meant by dependent variable? It is an outcome. Okay, what is m? Slope of the line, representing the relationship between the two variables. That is, the line will be like straight or somewhat slanting, 90 degrees, 60 degree, 30 degree, like that. Okay, that is what the slope. What is x? It is the independent variable. That is, you consider this as an input or a feature. Okay, for in order to predict the y, that is the outcome. What is c? It is an intercept, the value of y when x is 0. Okay, when the x value is 0, what is the value of y? Okay, yeah, this I hope like this is gonna be very very simple. Okay, whenever linear regression comes to your mind, what is the black box behind the linear regression? It is the formula y is equal to mx plus c. That's it. Okay, hope this is what the black box. Okay, so for this algorithm, yeah, y is equal to mx plus c, which implies that is it is a linear regression algorithm in the machine learning, which comes under like supervised learning, which comes under regression. Okay, so that is what the classification. So if whenever you just remember about, or we are thinking about linear regression algorithm, you just need to think of y is equal to mx plus c. That's it, where y is the outcome, x is the input, m is the slope, and c is the intercept. That's it. Okay, so yeah, that's what all about this linear regression equation. Yes sir, over to you.
Yes. So linear regression equation, let's understand it. So equation is y equal to mx plus c. Okay. So y is dependent variable. If we understand and split it, break down the equation. So then m is the slope of the line. You understand what is line, right? The slope of the line, which is like in the graph, you will, if you see that, if you if you make a graph and complete graph for this, so you'll understand that it is a slope of line representing the relationship between variables. That's what you have to understand. If you have y and x axis, wherein you will see slope of line representing relationship between the variables. Okay, then x is dependent variable, c is interceptor, the value of y when x is 0. Okay, so that is what you have to understand, because this is the black box. This is where magic happens, and this is where uh, the function of algorithm, the calculation happens. So if you understand this, beyond this there is nothing. This is the thing, the concepts, the application, and the black box. So these are three things which actually make the magic, and the data. And right data, clean, pre-processed, non-biased data as per the objective function. So this is where the magic happens, guys, with this black box calculation. And it's very simple. You can see y equal to mx plus c, but it is very very powerful regression, linear regression equation, guys, and there happens that linear regression magic. These are the components and like breakdown of the equation so that you guys can understand properly. So great, so let's move to the other slide.
Yeah, sure sir. Yeah. So moving on, guys. So okay, there is an assumption whenever you need to apply this linear regression model onto the data set, right? There is some assumptions. Okay, you guys need to understand. First is linearity. The relationship between the variables should be linear. Okay. Okay. I have said a concept, right? If you study for an hour, your mark will be 1. If you study for 2 hours, your mark will be 2. So like that, there is a linear relationship, right? 1 1, 2 2, 3 3. That is a linear relationship. That is, whenever the value of input variable, that is the feature, that is the independent variable increases, that is the hours of student study increases, the mark that a student obtain, that is the outcome y, is also increasing. So there is a linear relationship between the variables, then only you can apply this linear regression algorithm. Then independency, the data points are independent of each other. Yeah, that also one of the very important thing. The 2 or 3 data points if you are having in the data set, it should be independent of each other, then only you can able to apply this linear regression algorithm. Next, homoscedasticity. So that is, you guys need to have a understanding of the variance of the errors is constant across all the values of the independent variable. Okay, so when you are getting an error for one prediction, it will be same. Okay, if you are getting an error 0.20, then the 0.20 error will continue for all the data points. If you are having 10 data points, the error will be 0.20 for all the 10 data points. That is homoscedasticity. Okay, next, normality, the error are normally distributed. This both the things are more or less same. Okay, there the error is constant, here the error is normally distributed. Okay, if you are having 100% error, if there are 10 data points, 10% of error is normally distributed to along all the data points. Okay, so from my perspective, you guys need to, from this, what is the assumption you guys need to have in the mind is that you can apply the linear regression model to the data points which are linearly associated with them. Okay, that is either positively related, negatively related, like that should be. There should be, if you should not apply a linear regression model to a data point which has no relation. Okay, that's a main assumption that you need to take away from this slide from for me. Okay, so yeah, yes sir, over to you.
Yeah. So assumptions of linear regression, like first is linearity, like relationship between variable is linear. Linear means it's in linear comes from line, Linear. Okay. So if you see that word properly, so you'll understand that is what is linearity. It is in a variables in a linear fashion. So line, if you see line fashion, linear, that's what is called linearity. Okay. Second is independence. The data points are independent of each other. That is what in linear regression, that is what it is. So the data points are independent in each other. They are not dependent. Okay. Homoscedasticity. So the variance of the error is constant across all values of the independent variable. So the that is what it is. So the variance of the error is constant across all values of the independent variable. So that is like you can call it they are constant across. So normality. So normality is the like the errors are normally distributed. That is what is called normality. So they are normally distributed. That's what we want, guys. Our data should be normally distributed. That should be normalized. Okay. Okay. So that our model is not biased. There shouldn't be outliers, or it should not be skewed towards, like it should not be skewed towards right or left. It should be normally distributed, right? So then and only our model will learn properly. Otherwise, it will be biased. It will not. There would be underfit, overfit, a lot of things, a lot of errors and performance problems will come. So let's move to the other slide.
Yeah, sure, sir. Yeah, guys, like we will pass here. Actually, we have introduced you to the first algorithm in machine learning, which comes under supervised learning and under regression. Okay, today we have introduced you linear regression. I hope like you guys have a mathematical foundation also. Whenever linear regression comes to your mind, you guys need to have an understanding of it is y is equal to mx plus c. That's it. Okay, where y is the dependent variable, that is outcome. X is the independent variable, that is input, that is a feature, where m is the slope and c is the intercept. Guys, this much understanding is enough for us to play with the coding. Okay, So yeah, so we will pass here, and you guys need to know about the assumptions also. Okay, so we will pass here and we will continue this linear regression in the next session. And the next session we're gonna have a coding part of linear regression. So guys, till this point, if you guys have any doubts, please make sure that it is solved. Just post it in the comment and we are here to solve that. Okay, so yeah, that's the thing, guys. So make sure like you have watched this video, all the previous session videos, so that you can have a better understanding, because we're gonna jump into the coding parts. Okay, where before that you need to know about the knowledge of all the algorithms and their, like I will say, what is the black box of it. Okay, then only you guys can be able to understand when it goes for coding, because like coding is not gonna take a 2 lines of code. Okay, I'm just literally saying it will be only 2 lines of code. You just gonna call linear regression. That's it. Okay, everything else the inbuilt library is gonna do. Okay, so for me and for we, okay, we need you guys to be understand with the theoretical concept. Then we will be moving on to the answer. Okay, so yeah, that's it for this session. Hope you guys have enjoyed this session. So until the next session, we will all meet it, and we will all meet at the next session. And until then, bye guys, take care.
So, guys, go and watch all the sessions if you have come to this session. So, all the sessions 5 to 10 times, and subscribe to our channels. Also, press the bell icon so that you will get the notification. You will get the message whenever we are uploading new sessions. So, kindly write in the comment section what have you learned, how you're going to apply, and what is the objective function of your career, long-term objective function. So keep learning, absorb, have patience, consistency, persistency, and keep learning deeply. And we are there to help you. Just write in the comment section if you have any feedback, anything you want to change, improvement in these sessions. We are there to help, and we are there to help you continuously. Keep learning deeply. Thanks.
Yeah guys, thank you.